So welcome, my dears, back. Here we will go today for some topics. We'll go directly for some topics like we will talk about the partial factoring. We'll talk about the partial factoring, and here we go. Just we'll see this example for the partial factoring, and we will work on it, and we will solve this question of the partial factoring. Partial factoring means that is not the means the roots of the x and y or to get them. It means it's a way that we use to just simplify for ourselves how to get the x's. And also, if you see here in that question, use partial factoring to find the vertex. We will also look for the vertex here, then state if it's a max or min based on the coefficient of the ax square. So a here is greater than 0. So because it's not negative, it's positive. Once it's positive, means it's greater than 0. Then this will be a min vertex. But we will do this right now using the function. So we'll use the partial factoring. And also, here we go. We have the x squared plus 2x minus 6. Like you see here, we put the common factor on the other side as well. So minus 6 also became minus 6 here. So if we take this minus 6, this one there, to this side, it will be positive minus negative, that will be 0. Let us go for it one by one and check out what we are doing here, because we are trying to get the intercepts of x. We are trying to get out the intercepts of x. So what I will do here just now is that I will say 6 will equal x squared. Let me just adjust the stop share. I will stop share first, then I will go to my own, like here, it will be, I think it will be very clear like this. Yes, so here we can work now. So I will say y will equal x squared plus, I'm using partial P-A-R-T-I-A-L, partial factoring, F-A-C-T-O-R-I-N-G. partial factoring. So what I will do now, right now, this is an example, x squared plus 2x minus 6, and we need to get the x-intercepts. We want to get the x-intercepts using the partial factoring. So I will do what? I will put the 6 here and equal x squared plus 2x minus 6. Then I will take the 6 to the other side. By the meaning, that one is like you see here in front of you. Let's get it from here. Okay, guys. So I will consider this with this is partial minus 6. I just imitated. I put the minus 6 in both sides. Then this will be, if I move it to the other side, 6 minus 6 will equal x squared plus 2x. I moved this already to the other side. Now, this will equal 0, will equal x squared plus 2x. Cool. Now, I can take x as common factor. We'll take x as common factor here. So x 0 will equal x multiplied by x plus 2. Why this? Because x squared divided by x will give me x. And 2x divided by x will give me 2. Then I'll move forward right now. Into, I have two things now. I have x will equal 0. I have one of two things right now, the intercepts. X will equal 0, because this now, this multiplied by this will equal 0. So x will equal 0, or x plus 2 will equal 0. Whereas then x will equal, I will take the 2 to the other side, x will equal minus 2. So I have now 0 for x, I have 0 and minus 2. For x, I have 0 and I have minus 2. Those are for the x, 0 and minus 2. Those are for the x. Okay, Now this is a point. This is a point. Now I want to go to check out also what I will do with this. I will get the vertex. The x vertex is the average of these two intercepts. Here I will go in x vertex. The x vertex will equal the average of both of them. So it will equal 0 plus minus 2, 0 plus minus 2 divided by 2. So minus 2 divided by 2, that will give me minus 1. Then the vertex will equal minus 1. Then the vertex here will equal minus 1. Cool. That's nice. Then here now, I will substitute in the formula with the value of minus 1. Because I will not substitute with the 0. I don't need to substitute with the 0. I will substitute with the minus 1. The reason 0 is not a solution. So here I will go to the main formula where I will say now y will equal, I got the point of x, it's minus 1. Then I will go to get the point of y. Y will equal minus 1 whole square. Notice that I'm substituting here. Let me write the fact right back where I will substitute so that it will be clear for you guys. I will get the y now. How I will get the y? I will say y will equal x squared plus 2x plus 2x minus 6. That's a y. So what I will do then, I will say the y will equal x squared. I got the x for minus 1 whole square plus 2 multiplied by minus 1 minus 6. I only substituted now in this formula. So that will equal, y will equal minus 1 square minus 1 square. It's minus 1 square. That will be plus 1. Plus, and this is minus 2. So this will be minus 2. 2 multiplied by 1 by minus 1 minus 2. Minus and plus it will be minus 2. And this is minus 6. So here now, 1 minus 2 is minus 1, and minus 6 will be minus 7. So I have the point now of the vertex. The vertex point will be x is minus 1. So here I have the point will be minus 1 and minus 7. I have the vertex point is minus 1 and minus 7, as you can see here. And y, is it a min or max? Just I'm asking you a question. Is it a min or max? Of course, it is a min. So here it is a min. Why it is a min? Since a, we would say like this. Since a is greater than 0. What is the a? What is the a? The a is the factor in front of the x squared. So it's 1, which is greater than 0. Then the vertex is min. The vertex is min. The vertex will be min. As long as it's less than 1, then the vertex here, the vertex will be min. That's everything regarding this example. We'll go now to the second example. Way to the second example in this today. So this is the way we call it partial factoring. Like I'll show you, we call this partial factoring. And also, let me go and share the screen so that we can see what we are going to work on the upcoming parts. Let's go now, take our points, then we will go into 78, slide 78. Actually, the others are some same. Here we are going for the roots, and we will see what the meaning of radicals. Here, the radicals are the roots. So this unit is about the radicals and how to work with the radicals. You know, from the radicals, I will just tell you the rules of the radicals. just review it quickly so that we will have an idea about it. Let me just open the screen here, stop the share, and go right now into the radicals and the radicals as well, how to calculate the radicals. So here we go. The first thing is root of A multiplied by the root square of B. That will give me the root of AB. So as example, the root of 5 multiplied by the root square of 4, that will give me the root of 20. This is the first point we want to talk about. Okay, second point we want to talk about is the root of any amount, like root of any amount will be, that is here, let's go to another idea. So here we'll go to another idea. Now, I will just open the portal for you guys to see. So I will open here the our own, you can see here, because I just want you to know this practical parts and this parts which we are working through now. I just want you to understand it. Some numbers cannot be expressed as fractions. That are called irrational numbers. One type of the irrational numbers of this is the form of the root of n, where n is not a perfect square. There, these numbers are sometimes called radicals. An approximate value can be found for these irritation, like numbers which is not exactly the numbers which we want as exact. So now I just want to go now with you for some solutions for some questions. Let me also show some other things regarding the radicals, or the radicals also. Like if I say right now, here I have this in front of you, the root of 50, and the others are the same idea, the root of 50. So once I would say the root of 50, I'll stop the square share. If I say the root of 50, that means it's the root square of 2 multiplied by 25. This is under the root. That will equal the root of 2 multiplied by 5 power 2. This is under the root. That will equal 5, the root of 2. Because the root square of 25 is 5. So I will take the 5 out, and it's still inside, the 2 is still inside here. But you guys, same idea on the other two examples. So I will not go too much here now, and I will go to another idea. We'll go to another idea. So this is a slide 78. Then I will go to slide 81. We'll go to 81. Okay. We have here also an idea about 9 square 7 minus 3 square 7. So as example, if I have now two roots, if I have two roots, it's very simple, and you guys will get it very quickly. You guys will get it very quickly. Let me just show you. Take the example from the 9 root of 7 minus 3, the root square of 7. Okay, so this is very simple, guys. Very, very simple, because the root is common in both of them. The root is common in both of them, like you see here. 9 root 7 minus 3 root 7. It's like in both of them, so that will equal. The root of 7 is there, will be written there, the root of 7. 9 minus 3, that will give me 6. So it will equal 6 root of 7. I know some of you guys are saying this is very things we had before when we were in schools and this and that. I know, I'm quite sure of this. So let us go to the other example. Let us go for another example also for the radicals here. And we will go to this example. The example is saying to me that 4 root of 3, I will just show it to you right now, minus 2 root multiplied by the root of 9 multiplied by, this is amount, and multiply by the root of 3. And I just want to get also this amount. So here we can say that this is, take it like this, one step by one step. So 4 root of 3 is here the same, minus 2. The root of 9 is 3. So 2 multiplied by 3 multiplied by the root of 3. 2 multiplied by 3 multiplied by the root of 3. Cool. That's very nice. That is very nice. Then that will equal 4 root 3 minus 2 multiplied by 3. That will give me 6 root of 3. Here it is. If you can see it here. 4, the root of 3, this is the root square of 3, minus 6. 6, why? Because 2 multiplied by 3 will give me 6. The root of 3. Then I will say here, this is the root of 3 as long as it's common in both of them. This is the root of 3. Then 4 minus 6, that will give me minus 2. So it will be minus 2 multiplied by the root square of 3. And this is another example about the roots as well. We'll move right now into another slide and see what we have today. This is a slide of 81. We'll go to slide 83. Yeah, here is an example. Okay, here, this example also about the roots. I will just write the example, then we will solve it together. We will work on it together. If I say like this now, solve the question, 2 on the root square of 3, multiplied by, this is a whole sum, multiplied by another sum, 3, the roots of 6. 3 multiplied by the root of 6. So I can do like this. I can do like this. Now, how I will do it, I will tell you. I can do it like this. 2 multiplied by the root of 3, this is the root of 3, multiplied by the 3, the root of 6. Okay. I can say now 2 multiplied by 3. 2 multiplied by 3, that will equal 6. It's 2 multiplied by 3. And I have here 3 multiplied by 6. I said before that the root of A, the root square of A, multiplied by the root square of B will equal the root of A multiplied by B under the one root. So here, and this is here, so that you guys know. So this will be 6 multiplied by 3 times 6, which is 6 root square of 18. 6 root square of 18. Cool. That's very nice. Okay. 6 will equal 6 the root square of 18, which means also that it is 6 and the root of square of 2 multiplied by 9, because 18 is 2 multiplied by 9. Cool, that's nice. So I can take the root square of 9 outside now. So the root of outside of 9 will be 3. 3 multiplied by 6 will be 18. So it will equal 18 the root of 2. Because 9, I will get the root square of 9. This 9, I will get the root square of this 9. The root square of 9 is 3. 3 I will multiply it by 6. It will give me 18. And then what will still remain here? The 2 under the root. The 2 will be under the root. This is another example. We'll go to another example about the roots also. We have a lot of examples about the roots itself. Now we will go into page 484, which is the next slide. The next slide. On the next slide here, we have, I will just write it down, then we will work on it. Is it okay, guys? Let's go for the next one. So if I say here now, 2 multiplied by the root square of 3, and this is multiplied by 4 and plus 5, the root square of 3. So what I don't do now is just to multiply the first amount. This amount I will multiply by 4, then the same amount I multiplied by the other one. So it will be 2 multiplied by 4 the root square of 3. 2 multiplied by 4 the root square of 3, plus 2 multiplied by 5, 2 multiplied by 5, and again the root square of 3. Here, the root square of 3 multiplied by the root square of 2. So 2 and 5, this is okay, and root of 3 multiply also by another 3, because the 2 root of 3 multiplied in this number, 2 and 5, this is 2 and 5, and 2 and 3, the root of 3 multiplied by the root of 3 will give me the root of 3, another root of 3. So this will equal 8 root of 3 plus 10. Now this is the root of 9. 3 times 3 is 9, which is 8 the root of 3. Here we go. 8 the root square of 3 plus 10 multiplied by 3 root. There is no any root now, because the root square of 9 is 3. So there is no any root. So that will equal 8 root square of 3 plus 30. And this is the end of the example. Again, I will say 2 root square of 3. It is multiplied in by 4 plus 5 root square 3. So what I will do, I have to multiply 2 root of 3 once in the 4, multiplied by 4. Then another time, the whole amount here, I will multiply by 5 root of 3. So when I multiply the first amount, 2 root square 3 multiplied by 4, it will be 2 multiplied by 4 root square of 3. This is root square of 3. Plus the same amount, I will multiply it by this amount, So here I would say right now, 2 multiplied by 5, here is the 2 multiplied by 5, and the root square of 3 multiplied by the root square of 3, this is the root square of 3 multiplied by the root square of 3 here. So 2 times 4 will give me 8. 8 root square of 3 plus 2 times 5 will give me 10. 10 what? Root of square of 3 multiplied by the root square of 3, that will give me the root square of 9. So 10, the root square of 9. But I know that the root square of 9 is 3. So this will be 10 multiplied by 3. How about this one? It's the same. 8 root of square of 3. Finally, the final step here, at the final step, 8 root square of 3, 8 root square of 3, plus 10 times 3, that will give me 30. And that's it. So this is another example. It was on the page of 83. We'll go now to 93, take a leap into 93 and see an example there on the 93. Let's go there and see. Here are the solution. Find a solution for this example. We are factoring here. Solve the following quadratics by factoring. We have to factor this amount. X square. Let me just write the question down. Solve by factoring. Solve by factoring. Solve by factoring. We need to solve by factoring. We have x squared minus 15x plus 56 will equal 0. Okay. So here, to solve it, I will do the factoring. Here in the example, solve by factoring. Solve by factoring. X squared minus 15x plus 56 equals 0. By factoring means what? That I will get two values for x. I will have here two values for x when I make the factoring. How I will do the factoring? Just let me remind you with how to do the factoring. And the factoring itself, we used to do like this. And we will put x squared is x multiplied by x. How about I need two numbers. When I multiply them, they give me 56. And when I add them to each other, they give me 15. Again, I need two numbers. When I multiply them, they give me 56. When I add them together, they give me 15. So 7 multiplied by 8. When I multiply them, they will give me 56. That's right. And when I add them, 7 plus 8, they will give me 15. Then I'm right. So here I will say this is 7 and this is 8. Cool, guys. Once the signal of the last number is positive, then it will take, the middle one will take the signal of both of the, like here, I will just show it to you right now. So both will have, as long as this is positive, the last number, the signal is positive of the last number, then both the brackets will take the coefficient or the signal of the middle number, okay, or the coefficient of x. They will take the signal of the coefficient of x. So here it will be minus and minus, because x here is minus. The last number is plus, here it's plus. So both the brackets will take the signal of the coefficient of x. Okay, now that means what? Here it is, x minus 7 multiply by x minus 8 will equal 0. Okay, if I say now a multiplied by b will give me 0. That means what? A might be 0 or b might be 0, because any number multiplied by, if it is 0 and multiplied by other number, it will give you 0. Any number. If it is multiplied by another number, it will give you 0. So here I will have two solutions for x. I will say x minus 7 equals 0, or x minus 8 will equal the 0. If x minus 7 equals 0, by the way, I do the 0 like this just to make it different than the O. So you guys can do it like this or do it like this. It's okay. It's left up to you. Then x minus 7 equals 0. Then x will equal, I will take the minus 7 to the other side. Then x will equal 7. Then x minus 8 will equal 0. Then x will equal, I will take the minus to the other side. Once I pass the equilibrium here, this here, when I pass the equilibrium, equal, I pass it to the other side. The negative become positive and the positive become negative. So if it's negative, it will become positive. So it will be 8. So x will equal 7 or x will equal 8 for this solution here. That's what I want. Okay, guys. Same likewise in the next page. So we don't need to do this again. And after that, we'll go into page 99. 99 to see the solution of the example on the page 99. In this example, we have here the axis of the asymmetry. Same example which we did, but we will get also the axis of asymmetry which we had here, because we said the axis of asymmetry is the average of the x median. So we'll do the same thing. I will do it on this one now. I will do it on this one. So if I want to find, now I got this. If I want to get the axis of symmetry, if I say the axis of symmetry, if I want to get the axis of symmetry for this example, let me just take it down like this so you guys can see it. If I need to get the axis of symmetry, it will be the average of the axis. It will equal the average of x's, which I have. So I have the average of x. So I can get 7 and 8 divided by 2 will equal 7 plus 8 divided by 2. 7 plus 8 divided by 2. Here it is, 7 plus 8 divided by 2. 7 plus 8 divided by 2. That will give me 7.5. So the axis of symmetry will be 7.5 here. And by the way, also, we can get another things. We had it before as example. If I want to get, is it the turnover point, or it will be what? It will be minimum, because a here, ax squared is greater than 0. Since 8a is greater than 0, then my point, it will be the point which I need here, it will be, this will be min. It will be min, like this. So this is min, because the curve will be by that way. The curve will be done. That's for the moment. The things which we need to know. We'll go now to page 114 and see. another example to the page 114. So this is the vertex, like we said, the vertex here, A, and the vertex will be min. Vertex min. Vertex will be min. This is, we have some factors. We cannot, some factors in real life situation, we cannot put them in a figure like, let me just explain it here. I will write the example, then we'll go to solid. Some functions, we cannot break it up. We cannot get a value like it's, we need to get here roots for it. It's difficult to get these roots using the previous ways, because when we try to factor it, it's unfactorable. So I want to say here, some functions, can not be factored. The word factor means we cannot compose it like we did two brackets and then will equal 0, then will one x will equal this will equal 0, then the other one will equal like that way. So we cannot factor it. It's unfactorable. Unfactorable. We call it unfactorable. Unfactorable. Like here, it is unfactorable. We cannot break it up. For that reason, that's why we use this relationship, which I will write to you right now. So we used to get the x's, the x values here will equal this relationship minus b plus or negative b squared minus 4ac divided by 2a. Take care that the 2a, the a here, this is 2a, and the a is not within the root. The root is out of the a. So what is this about? What is the a and what is the b? I will tell you. We have the equilibrium like this on this form, ax squared for the quadratic form plus bx plus c. So the a is here. This is the a, the coefficient of the x squared, or the constant in front x squared. This is the a. What about the b? It's here. This is the b. This one is the b. What about the c? This is c. As example, let me say as example, I have this equilibrium. I have this equilibrium, 3x squared plus 2x plus 6. So to apply this formula, a will equal 3. Here is the a will equal 3. B will equal 2. B will equal 2. And C will equal 6. C will equal 6. You guys got it? So that's how it works. This is how it works. So the a is the coefficient in front of x squared. The b is the coefficient in front of the x. And the c is the absolute margin where there's no x's. Okay, let me apply this right now here on this formula. Let me apply this on the formula. So it will equal, to get the x points here, I will say like this, it will be minus b. Minus b means minus 2 plus and negative the root square of b square. B square here, I have the b for 2. 2 square. Here I will just make it enlarge just a little bit. I know 2 square. B square minus 4 a equal 3 in 3 4 multiply by 3 multiply by the other number, which is c. C here, c equals 6 divided by this, all divided by 2 multiplied by a again. 2 multiplied by a. So the 2 multiplied by a, 2 multiplied by 3, because a equals 3. And then I will finish it. The most important part is inside the root here. This number minus this number, like this example now, has no solution. Simply because this is 4 minus, this is 72. 4 times 3 is 12 times 6, 72. So it will be minus under the root, means no solution for this example. As long as the number after the minus, if it is greater than before the minus, then in that case, no solution for the example. There is no meaning and no solution for the example. You guys got it now? What is the A? What is the B? What is the C? And we'll apply this formula. When we apply it, if I found the example which I gave you is not factorable, means I cannot put it, decompose it into 2 brackets or whatever, and get the value of x. In that case, I have to use this, the root. We call it the root. Some function cannot be used by this, so we use the roots for that purpose. Okay. Time come now for me to solve a question. And here is the question which we will solve. Here it is. If I say like this, here I will say, or x squared plus 24x plus 24x. It will be shown up to you right now, guys. Plus 36 will equal 0. Then, here we go, guys. I hope that it's clear now. And I'll try to do the factorial operations which we did before, but it didn't exist, and it was not, we are not able to factor it. We are not able to factor this amount. In that case, I will take a common factor here, which is 4. Then this would be x squared plus 24 divided by 4. That will give me 6x plus 36 divided by 4. That will give me 9. Of course, 0 divided by 4, because here I will be 0 as well. So I can divide both the sides by 4. 4 by 4 will be 1. We don't need to write the 1. So it will be x squared plus 6x plus 9. And 0 divided by 4 will be 0. nothing changed. If I try to factor this, it might doesn't work. It might doesn't work because I need two numbers. But here it might work because 3 times 3 is 9 and 3 and 3 is 6. So it might work here. But I'm just using now the roots for another way to solve this question. I will use the roots here. So what? Let us use the roots. How about what is the data which is given here? Ax squared. How much is the x here? How much is the x in front of me here? We have it's 6 here. And yeah, so now a will equal 1. Ax squared, a will equal 1. B will equal 6. And C will equal 9. A will equal 1. Here is 1. 1x squared means 1. 1. B equal 6. C equal 9. Then I will apply the formula. I will go to apply the formula. The formula is telling me x will equal minus b plus or minus the root square of b squared minus 4ac divided by, all this is divided by 2a. This is 4ac, just I will enlarge it, 4ac, because it was not very clear. Cool, guys, that's very nice. Okay, I will substitute now in this formula. I will substitute in this formula. So I will say here right now that will equal minus b. Let us make it like this. Then minus the b is how much? 6 minus 6 plus or negative. The root square here is the root square of b square. B square means 6 square means 36 minus 4. The 4 is constant. A equal 1. And C again equal 9. You guys can see it. I think it's clear for everyone. And then down, divided by the 2 in A. 2 multiplied again by the A, and the A equal 1 here. Let me finish it and see how much it will be. 6. That 6 is outside. Plus or minus 36 minus 4 and 1 and 9, 36. So this will be the root square of 36 minus 36 divided by 2. Take care, 2 times 1. Take care that the 2 is not, the 2 is not in the root, is not included inside the root. And that will equal minus 6 plus or minus the root of 0. Because 36 minus 36 will give me 0 divided by 2. So that will equal minus 6 plus or minus 0 means it's nothing here because I will not add anything or I will not subtract anything. Nothing to add or to subtract. Minus 6 divided by 2. Then x will equal minus 3. X here will equal minus 3. That is for the point. I just want to show you when we use this factorial, it goes by that way. using the factorial. It goes like that way. So I have, in this case, this amount is 0. Then there is one solution only. Why? Because this amount is 0. So I have only one solution. Means x has only one value. But suppose there was a number here. There was a number here in this. Then we'll have positive and negative. Once we will add it and once we'll subtract it. Then we will have two values. Right. If, like the previous example, this amount under the root was negative. In that case, if this amount under the root is negative, then we say no solution. There is no solution. That's why I just want to put it for you right now in a figure of equilibrium. We are done for this example here, actually, but I just want to put it for you in a figure of equilibrium. And this part, I just want to put it in a figure of. Now I will go back to this relationship again. And I would say like this. If this amount, we said that x will equal minus b plus or minus b squared minus 4ac divided by 2a. Now I would say if, please write it down, if the root square of b squared minus 4ac, if this is positive, if this number, when you calculate as example, you got root 16 or more than 1, greater than 1, then we have two solutions. By other meaning, we have two values for x. Two values for x. If this amount was 0, like the previous example which we did just now, then we have only one solution, which means one value for x. We have one value for x. But if it was minus or less than 1, this is greater than 1, this is less than 1, in that case, we say no solution. In that case, we say there is no solution for this exercise or for this example. It depends all on this amount. On this amount here, this amount, b squared minus 4ac, this amount, if it is positive, greater than 1, we have two values for x. If it equals 0, we have only one solution for x. If it was negative, we don't have any solution for x. That was for that point right now. And I'm moving forward right away into the next part. I will move forward to the next part.